Hello everyone, I welcome all of you again in my next online class. Today I think this is 7th lecture. So this 7th lecture, today we'll solve some numericals mainly. Already we have finished every topics, each and every topics clearly. So I hope there is no doubt on that. Okay, so today we'll start. We'll just try to solve some numericals. The numericals I picked from gate question papers. So it will just try to clear the concept. Just will try to help you to clear all the doubts whichever you have. So yes, before I start this, numericals. First, I'll say some one line that whenever you find any problems or any numericals anywhere means just see the units. In which units the values are given. If you find the values are given in different units, then blindly convert the units into SI units, because that is the most important task. Actually, what happens in many GATE question papers, it has been found that they just trick you with the units. Suppose they have given all the values in SI units, and later they ask you to calculate the value into something MKS or some different units. Okay, so there you just get the trouble. So it's always advised, whatever units you find, first you convert into SI units. Okay, and then after converting into SI units, you calculate the answer. After getting the answer in whatever unit they ask you, convert into that unit and just give the answer. That's it. So this is the most important thing, okay, before starting numericals. So let's start then one by one numericals we'll see, and we'll just try to solve it. So in the first numericals, you see it is said that if weight basis moisture content of paddy is 20%, then calculate the paddy moisture content in percent dry basis. So if WB, weight basis moisture content, is 20%, then calculate dry basis moisture content. Now already I know the formula, the relation between dB and WB. If WB is 20%, then what is the value of dB? I know the formula. The formula is dB equals to WB by 1 minus WB. I can simply use the formula, but no. Before using the formula, just using the concept, we can solve or not, that we'll try. So first, what I have seen, what I've taken, weight basis 20% is given as it is I've written. Then what I've said, weight of product. Weight of product, you assume that 100 grams of or 100 kg of product is present. So if 100 kg of product is present and then 20%, then what you can write? So in 100 kg, 20 kg of water. So in 100 kg of product, how much kg of water will be there? So what you can do? We can do here, see, 20 by 100 into 100 means 20 kg is the weight of water in 100 kg of product. Now, if in 100 kg of product, 20 kg is the weight of water, the rest mass, 100 minus 20, 80 kg. What is this 80 kg? Is nothing but the mass of solid. So 80 kg is the mass of solid. Now in dry basis, the formula of dry basis is mass of moisture by mass of solid. So what you can do, mass of moisture is given here 20 kg and mass of solid it's 80 kg. So that's why I can write this 20 by 80 equals to this 25%, 0.25. So if we multiply this, then we get the value of dry basis in 25%. Now, same problem if we use the formula that dV equals to WB by 1 minus WB. Then I can just put the value of this WB in decimal. So 0.2 by 1 minus 0.2. So same 0.2 by 0.8, it comes 0.25 or 25%. So directly by using the formula or by using concept, we can solve this numerical. So this is not a big problem. Going forward, let's start one more solution. Next problem is, see, sample of wheat is dried in thin layer at 65 degrees Celsius. So at what temperature the wheat is drying? 65 degrees Celsius. Now, moisture content interval at 0 hour, 1 hour and 2 hours. Means at 0 hour the moisture content is 25.3%. Again after 1 hour of interval the moisture content is 18.5%. So the value will reduce or it will increase? Yes, obviously it will reduce because it's drying. So moisture content will reduce from 25.3% to 18.5%. Next, again moisture content interval after 3 hours. So after 2 hours. So after 2 hours again it is reduced from 18.5% to 15.9%. All in dry basis. Calculate the equilibrium moisture content. So in this case what we will do, at 0 hour the value of moisture content is how much? 25.3%. At 1 hour the value of moisture content is how much? 15.5%. And at 2 hours, after 2 hours the value of moisture content is 15.9%. So in first two, if we take from 0 hour to 1 hour, means from 25.3% to 18.5%. If we take this case, then we can use the formula moisture ratio equals to exponential of minus kT. Moisture ratio means what? M minus Me by M naught minus Me. So M is the final moisture. So what is the final moisture after 1 hour? Yes, it is 18.5%. What is the initial moisture? It is 25.3%. Do you know the value of equilibrium moisture content Me? No, I don't know. So that's why Me is unknown. Equals to exponential of minus kT. So exponential of minus kT means we can write drying rate constant we don't know, but T also we know. How much is the time interval? From 0 hour to 1 hour means 1 minus 0. How much? 1 hour. So we can write 18.5 minus Me divided by 25.3 minus Me equals to exponential of minus k into 1. So in the next line, this exponential you take in the left hand side, so it becomes ln of 0.185 minus Me divided by 0.253 minus Me equals to minus k into 1 or minus k. In the next line, same thing, if we proceed, then we have another one case. So in that case, the value is reducing from 25.3% to 15.9% after 2 hours. So again we can use the formula of this moisture ratio. So moisture ratio MR equals to exponential of minus kT. So now if I replace the value, so M minus Me by M naught minus Me. So what is the value of M now after 2 hours? 15.9%. Now 0.159 minus Me divided by M naught. Now what was the initial moisture at the beginning? 25.3%. So that's why 0.253 minus Me equals to exponential of minus k into T. Time interval how much? From 0 hour to 2 hours. So it is 2. So minus k into 2. Now if I simplify, if I take the ln in the left hand side, it becomes ln of 0.159 minus Me by 0.253 minus Me equals to minus 2k. Now in this first and second equation you have to take it, if I divide, then left hand side becomes ln of 0.185 minus Me divided by 0.253 minus Me divided by upon ln of 0.159 minus Me by ln 0.253 minus Me equals to minus k by minus 2k. Now in the right hand side we can cancel this minus minus and we can cancel k and k. So now if I cross multiply, then in the next line we get 2 into ln of 0.185 minus Me by 0.253 minus Me equals to ln of 0.159 minus Me by 0.253 minus Me. So this now what we'll do, in the left hand side you have 2 into ln of something. So we know the formula of A into ln B. The formula is ln of b to the power a, means whatever the left you have, that will go in the power. So same thing, 2 will go in power. So in the next line, what you do, ln of 0.185 minus me divided by 0.253 minus me whole square equals to ln of 0.159 minus me by 0.253 minus me. Now this both side ln and ln we can cancel. This, we can remove the function. Then ultimately it comes 0.185 minus me whole square by 0.253 minus me equals to 0.159 minus me. So after simplifying this, we get the value of equilibrium moisture content is 0.1429 or 14.29% dry basis. So this was the second solution or second problem. Now going to the next question. First again, I'll first read the question. Initial moisture content of product is 31.6% dry basis. So, and it is reduced to 14.9% dry basis after drying. If the value of EMC is 5.3% and drying rate constant is 8.33 into 10 power minus 3 minute inverse. Now see, be careful, this is given in minute inverse. So what we'll do, first you convert the value of minute into second blindly, and then calculate time required to reach the desired moisture content. So how will you solve this? We have to calculate the time value to time required to reach the desired moisture content. From where to where? From 31.6% to 14.9%. So the formula we use here, what? Tell me. Yes, moisture ratio. Moisture ratio equals to exponential of minus kT. So here moisture ratio equilibrium EMC is given. Yes, EMC is how much? It's given as 5.3%. So let's start then. Initial moisture content is 31.6% dB. Final moisture content is 14.9% dB. Then EMC value is 5.3% dB and K value is given in per minute inverse. So if we convert it, it is becoming 8.33 into 10 power minus 3 minute inverse. The next line we can write this in 1 by minute. So 1 minute means how much? 60 seconds. So that 60 seconds we'll write in the top or in the down? Yes, we'll write in the down because minute is in down. So we write down. So 8.33 into 10 power minus 3 divided by 60, 1 by second, and then finally if I simplify, it comes 1.39 into 10 power minus 4 second inverse. So now if we put this in formula, m minus me by m naught minus me equals to exponential of minus kt. So m is how much? 0.149 minus 0.053 divided by 0.316 minus 0.053 equals to exponential of minus k. K how much? 1.39 into 10 power minus 4 into t. T we have to calculate. So if I simplify it, the time comes 7250 seconds. So 1 second means how much hour? 1 by 3600 hour. So we have to divide this by 3600. So it comes 2.01 hours, means almost 2 hours. So this is the solution for the next question. This question. Okay. So next, going to the next question. Here you see food grain is present at 90% RH. And equilibrium moisture content given at that condition is 30% dry basis. Again, same food is kept at 70% RH. Now you tell me the value of EMC will be lower than this 30% or higher than 30%. If you reduce the relative humidity, that means the air is having less vapor or less vapor pressure. If the air is having less vapor pressure, that means the air will gain moisture, it will lose moisture. It will lose moisture. So certainly the EMC value will be reducing. So EMC value is now 20%, is reduced to 20% dB. Environment is maintained at 27 degrees Celsius So calculate the value of C and N from Henderson equation. So it's directly given Henderson equation. We know the formula. So first we'll write 90% RH and how much percent dry EMC? 30% dB and 70% RH in the next one and 20% dB. So we know the formula, Henderson equation, 1 minus RH equals to exponential of minus C T me to the power n. Now if I put the values in the first case, in the equation, the first case, the relative humidity how much? 90%. So I know the RH value should be given in decimal. So 1 minus 0.9 equals to exponential of minus C, I don't know, T 27 degrees Celsius, and I know it should be in absolute temperature. So 27 plus 273 is coming 300. So multiply 300, then multiply ME how much? It's given 30%, and I know the value of ME should be given in percentage. So 30 to the power n also I don't know. So if I simplify, it's coming 0.1 left hand side, 1 minus 0.9, and this exponential if I take in the left hand side, then it becomes ln. So ln of 0.1 equals to minus C into 300 into 30 power n. Now ln of 0.1 minus 2.303 equals to minus C into 300 into 30 power n. So minus and minus both sides cancels out, and it comes 2.303 into C equals to C into 300 into 30 power n. So this is the one equation. Another one time we have another one case. So here also I can put the same formula, 1 minus RH equals to exponential of minus CT me to the power n. So 1 minus RH in decimal, so the value say 0.7. So 1 minus 0.7 equals to exponential of minus C unknown T 300 multiply ME. Now the ME value is 20% dB, and this 20% should be in percentage, so that's why 20 to the power n. Then in the next line, 1 minus 0.7 we can write 0.3, and again exponential in the right hand side, that if we take in the left hand side it becomes ln. So ln of 0.3 equals to minus C into 300 into 20 power n. Again ln of 0.3, the value is 1.204 minus 1.204 equals to minus C into 300 into 20 power n. So both sides I can cancel the minus. So then finally it looks like 1.204 equals to C into 300 into 20 power n. So these two equations, if I divide third and fourth equation, then it comes left hand side 2.303 by 1.204 equals to C into 300 into 30 power n divided by C into 300 into 20 power n. So ultimately it's coming 1.913 equals to 1.5 power n, and then if I take this log on the both sides, so it comes log of 1.915 equals to log of 1.5 power n. Next again if I take this log of this value, then it comes 0.21, 0.282, and in the next right hand side log of 1.5 power n, so that n we can write in the left hand side, the left side of the value, so we can write n into log of 1.5. So from there we can calculate the value of n is 1.593. Now you take any one equation, third, fourth, first, second, any one equation, and you put the value of n. So I have taken here third equation. So the third equation is 2.303 equals to C into 300 into 30 power n. So in that equation, now if I put the value of n, only one unknown is there, C. So from there 2.303 equals to C into 300 into 30 power 1.593. So ultimately it comes C equals to 3.4 into 10 power minus 5. So these are the values of C and N. So this is the solution of this question. Now the last questions is also one good conceptual question. You see, 250 kg of tomato having 95% dry basis moisture is dried to 25 kg of tomato. Calculate the moisture content removed and final moisture content in dB and in WB. So what was the initial mass of tomato? 250 kg. So in 250 kg of tomato, 95% dB is the percent of moisture. Now you have to tell me what is the mass of moisture then. So what you do here? So you just assume that 100 kg of tomato is present. Just assume. So 250 kg of tomato, in 250 kg of tomato, 95% dB moisture. So we can write 100 kg of tomato contains 95 kg of moisture. So 250 kg of product or tomato will contain 95 by 100 multiplied 250, means it's coming 237.5 kg of moisture. So 250 kg of tomato contains 237.5 kg moisture. So what is the rest of the mass? The rest of the mass is nothing but mass of solid. So that's why we can write this mass of solid is 250 minus 237.5, that is 12.5 kg. So this is mass of solid. Now they ask you that final weight of the mass is how much? Final weight of the tomato is 25 kg. So out of this 25 kg, 12.5 kg is the mass of solid. That doesn't change. That remains same. So that's why 25 minus 12.5, that mass is nothing but the mass of water present now after drying. So that's why I can calculate percent dB is mass of solid by mass of moisture by mass of solid. That means 12.5 by 12.5. So it's coming almost 100%. And WB we can calculate mass of moisture by mass of product. So mass of moisture finally how much? 12.5 kg. And how much is the mass of product present finally? 25 kg. 25. So it's coming 50% is the mass of WB. And how much amount of water is removed? So it's also simple. Initially 250 kg of tomato was there, and now 50 kg of 25 kg of tomato is there. So how much moisture is removed? Tell me. Yes, it is 225 kg of tomato is removed during drying process. So this is, there are some numericals we solved today. So after this, again we will start the next unit, second unit in our next lectures. So before that, you study the previous lecture, previous online classes, and see the videos. I hope that it help you in your further study. Okay, thank you.